simply supported beam of 5 meter span has a central downward load of 40 kilonewton. So we have a simply supported beam. A simply supported beam is one in which we have pin support at one end and the roller support at the other end. So we have a pin support at one end, and on the other hand we have the roller support. So this distance between the support is 5 meter. And it has a central downward load of 40 kilonewton. And we have a 40 kilonewton point load acting in downward direction and as well as at the center of the beam. And it has a UDL of intensity 3 kilonewton per meter. So we have a UDL that has an intensity of 3 kilonewton per meter, and we have to determine the support reactions for this beam. That is, if I take this direction as x and this one as y, we have to determine these reactions RAY and RAX, and at roller support we have only one reaction RBY. So RAY basically acts at a point and it's acting in y direction. Similarly, RAX is the reaction at a point and acting in x direction. So we have to determine these three reactions, RAX, RAY and RBY. To do that, we are going to apply conditions of equilibrium. Summation of f of x, summation of f of y, and summation of moment about a particular point. And all of these are going to be equal to 0. So first, let's use this condition to determine the reaction. So summation of f of x is equal to 0, and let's take rightward force as positive. So RAX is positive. Is there any other force which is acting in x direction? No. So this is going to be equal to 0. Now let's apply second condition of equilibrium and take upward force as positive. And how many forces are there which are acting in y direction? So we have this RAY, RBY, this 40 kilonewton as well as this UDL. So RAY is going to be positive since it matches my sign convention. RBY is also going to be positive. And we have this 40 kilonewton which is acting in downward direction, hence negative, and this 3 kilonewton per meter intensity of loading. So let's calculate the resultant load. The resultant load of this UDL is going to be equal to 3 multiplied by 5, which is 15. And it's also going to act at the center of the beam. So 3 multiplied by 5 is going to be 15 kilonewton. This is the resultant load of this UDL. And the resultant load of this UDL is also acting in downward direction, so this is going to be negative as well. And if you solve this, simplify this, you are going to obtain RAY plus RBY equal to 55. And let's name this equation as equation number 1. And now we are left with last condition of equilibrium. So let's apply that. Let's take summation of moment about a point, and let's take clockwise moment as positive. So how many forces are there which are creating moment about this point? So RAX and RAY won't be creating any moment because they are passing through this point. Whereas this 40 kilonewton force is creating clockwise moment about this point. So 40 kilonewton is creating clockwise moment and it matches my sign convention. This is going to be positive and it has a moment arm of 2.5. So 2.5, and we have this 15 kilonewton resultant load because of this UDL. This is also creating clockwise moment about this point. So this is also going to be positive and it has a moment arm of 2.5. Is there any other force which is creating moment about this point? We have this RBY which is creating counterclockwise moment about this point, and it opposes my sign convention, hence negative. RBY, it has a moment arm of 5 meter with respect to a point. And if you solve this, RBY from here is equal to 27.5 kilonewton. Okay, now substitute this value of RBY into this equation number 1, and 1 from here implies that RAY plus RBY, which is equal to 27.5, is equal to 55. And if you find this unknown from here, RAY is equal to 27.5 kilonewton. And these are your answers. That's it, we're done.